And now we're going to talk about the program you're enrolled in, because you are currently doing your master program, correct?
Yes.
Can you tell us a little bit about the program that you're enrolled in right now?
Yeah, absolutely. So the program I'm in right now is an integrated master's in engineering, and it's 4 years long. So you learn chemical engineering more generally with principles in the first 2 years, including things like design projects and laboratory work. And then you specialize in your third and fourth, and your degree title changes. So right now, I'm just generally enrolled in chemical engineering, Masters of Engineering. But depending on what modules I take in my third and fourth years, I could come out with, say, for example, a chemical engineering with pharmaceutical engineering degree or a chemical engineering with nuclear engineering degree. So, yeah, you can graduate after 3 years of study, but ideally, it's more valid to stay after, do the whole 4 years of integrated masters because you come out upskilled to a higher level and you're more useful in industry that way.
Great, thank you. And just so to be clear, so you don't really get a bachelor's degree along the lines, right? You only directly get a master's degree after 4 years.
That is correct. Yes, you don't really get a bachelor's.
Great. But now normally, a lot of people, they don't go down that route. Especially if someone is watching from a different country, they have that very stereotypical a bachelor degree and then a master degree. But you chose not to walk that path and choose this integrated program. Is there a specific reason that you chose this program and not the old-fashioned bachelor and then a master?
Yeah, absolutely. So in the UK, all the top 10 universities for chemical engineering, they all offer a 4-year integrated master's as the first choice, and with good reason. Because the way the industry is structured in the UK is for you to go into a higher level role fresh off graduation, they would like you to have a master's. So that's why I went into this role. I'd say there's definitely some advantages and disadvantages. One of the advantages is obviously it's 4 years of continuous study and that's it, you have your master's. So compared to the other group you were talking about, you do a bachelor's, maybe go into industry and then do an extra year or 18 months on top. But a disadvantage is the way the program is structured is you're almost discouraged from doing like a year in industry, because then that would make your years of study 5 years, which is a very lengthy period of time to study. So yeah, that's the reason I chose it.
Great. Well, thank you so very much for sharing that. Could you briefly tell us a little bit about the workload that you have in the program?
Yeah, absolutely. So I'll start off by saying I have nothing but praise for Imperial. The way they've treated me just these past couple of years has been absolutely amazing. I think their dedication to their students is very good, and they really provide you with all the resources. So the workload, it differs from years. So the first year is the lightest on workload. I would say some weeks you could be working up to 40 hours a week, but other weeks you could be as low as 32. So it really depends on what season it is, whether it's opening season or exam season. And one of the main key points about Imperial's system is they provide a lot of support, as I said. So we have weekly tutorials within the different modules where you have PhD students who come and tutor you. And you also have access to office hours and good support with your personal tutorials. So it's not just all about work. There is a lot of balance, and your mental health is well catered for as well.
Amazing. And it's always good to have this support system in place, especially when you are enrolled in a complex degree as chemical engineering.
Absolutely.
But then if I was to ask, how would you describe a very normal week at the university? Like, is it divided up on assignments, labs, and are you getting 8 hours of sleep?
That is a very good question. I'd say a normal week is quite linear in that we would have, as I said, around 40 hours of work. So we have around 15 hours of lectures, give or take, usually split up into 3 hours of lectures a day over 5 days. Obviously, some days it might be you have a 3-hour lecture and a 1-hour lecture the next day. So it's roughly around 15 hours a week of lectures. In terms of labs, they always come in blocks of 3 hours. So we have to do around 6 hours every fortnight. So 6 hours of lab work every fortnight, but that's only like structured. Everything else on top of that, so the work you do outside, that depends on how much you want to put in. 8 hours of sleep, I'll be honest. Sometimes it's not always possible, but it comes down to how much you are willing to give up to get the grade you want. So sometimes you have to put a stop to say, no, it's 11 o'clock. I have to go to sleep 8 hours. I need to be there tomorrow. Or other days you pull all-nighters because you know you've got assignments due. In terms of assignments, we do have a couple of those each term. So I would say we have at least 3 assignments each term. And the term is 10 weeks. So it's roughly around 3 weeks per assignment. So yeah, good split. And if you want to, I'd say if you want to secure a good grade, so a 2.1, or I think in GPA, that's around 3.4, you'd have to do around 6 to 8 hours of work each day, 7 days a week. So yeah.
Yep, great. Thank you very much for sharing that. But now you are, of course, currently studying chemical engineering. And I don't know if it has ever happened with you, but if you tell someone that you are a chemical engineer, they connect it directly with you being a chemist. They might even throw in a chemical question right after you. Like, oh yeah, do you know how many bonds there are in that specific chemical? Do you feel that there is some sort of connection between chemical engineering and chemistry?
Yeah, absolutely. So interestingly enough, I put out a tweet a couple of weeks ago saying that perhaps we should rename chemical engineering to mechanical engineering because it's closer to mechanical engineering than it is to chemistry. But to back up the answer to the question, I'd say there definitely is a link, but chemistry only makes up to around about 20% of the whole of chemical engineering. Because, as you said, people automatically assume, oh, you know, chemical engineering chemists, you must be doing the same thing. It's only chemical engineers aren't really concerned about the science behind how everything works. They're only concerned about the science that makes them a valid product that they can scale up. So I would say it's about 20% chemistry, but it's more physics and maths and probably about 5% biology. So there definitely is a connection, as I've said, but it's about a fifth.
Great. Well, thank you very much for sharing that. But now going back to chemical engineering, because now you said there are so many topics that you are looking at. You're looking at physics, math, biology, chemistry, then you have your engineering, then you have labs. Could you briefly describe like what sort of topics you have to deal with in chemical engineering and how the curriculum is set up in the entire program?
Yeah, of course. So in the first 2 years, as I said, you deal with your kind of bread and butter chemical engineering concepts before specializing in your third and fourth. So I would say in the first 2 years, you look at your process analysis, which is you essentially take a process. It could be anything from transporting oranges from a farm to a juice bottle, or something more complex like a heat exchanger for a carbon capture plant. And you simplify it down into a diagram, and you understand how everything flows and where things go to and from and the reactions that occur in between. So process analysis, definitely. Another huge one is thermodynamics. So everyone loves thermodynamics because it's essentially chemical engineering. It is the bread and butter chemical engineering module. So that's all about that's all about how things behave under different temperature, volumes, and pressures, and how you can manipulate systems to get certain environments out of them, and how things can be optimized better. So that's what thermodynamics is about. You also have your fluid mechanics. So that's all about how things flow. And if you've been watching my chemical engineering alphabet, you know I have a very big onus on fluid mechanics because it's a very term-heavy module. On top of that, you have separation processes. So this is your more kind of traditional chemical engineering. Like when you think of chemical engineering, you think, okay, oil and gas columns. That's what separation processes is. It's how things work in separations and different volatilities and all that sort of stuff. Maths is a very big part, of course, because maths is, well, it's an engineering discipline, so you'd expect a lot of maths. You also have your process design and control and your reaction engineering. So this is slightly more physics heavy. And you focus on why reactions occur the way they do and how you can best manipulate these reactions to get desired products at the end of them. And on top of that, I would say there is labs and design projects. So this is where you work with other members of other chemical engineering students to get a common goal, whether that's to carry out an experiment or to provide a consultancy brief, like in a heat exchanger problem, for example. So yeah, those are the main modules in the chemical engineering degree.
Great. And thank you so very much for briefly and really in detail explaining all the different topics. So before going into the chemical engineering school, what are the academic skills that students should be aware of right when they are getting out of high school?
I think that's a great question because there's obviously many answers that I could give, but I'm going to stick to the top two that I would like to focus on. So the first one I would say is good team working skills. And this is an academic soft skill because to work as a good chemical engineering student, you need to learn how to teamwork. There's excuse me, there's no two ways about it. You will always be working with your fellow chemical engineers, whether that's on an assignment or on a problem sheet or in labs. So team working skills is definitely a massive one. And add to that, I would say time management, because if you have good time management, you can navigate university life and chemical engineering specifically better, because chemical engineering won't be okay. You have one assignment a week and that's it. There's about 50 different things going on. You've got a product design module due tomorrow. You've got an assignment due next week. You've got labs that's due tonight. So managing your time, knowing when you're doing stuff, that's very important. So before starting chemical engineering, if you've got good time management and good team working skills, it's definitely the right degree for you.
Great. Well, thank you so very much for sharing that, Juproop. Then the final question I'll ask about your education is that, you mentioned all the chemical engineering hard topics, and those are, of course, given topics that are very common, something that every engineer needs to know. Then, of course, you have your basic labs, and then you have your basic science topics. But, in the recent times, the world has moved towards a very different phase of chemical engineering as well. For example, data science, programming, and all those other aspects that we need to be clear of. Do you feel that your university puts enough focus on these additional topics such as programming, Python, data analytics, and so on?
Yeah, definitely. Good question. I would say that Imperial is very, very focused on the cutting edge technology, because one of the main modules we have in our first year is we actually have a MATLAB, entire module dedicated to MATLAB, and we do that over the first term and second term. So in that we learn basics of MATLAB programming, and we complete the on-ramp course, which is the introductory course. But by the end of second term or midway through second term, we have a mini project due, whereby we have to use all the skills we've picked up to answer a real chemical engineering problem. So if I go back to an earlier example, the heat exchanger design. So we have to use MATLAB code to take data from a heat exchanger plant that's giving out data, and work out whether it's economically viable and whether the separation process is running at the correct efficiency as it should be. So that's quite a big focus on non-hard sciences. But we also have other things that we focus on. So we learn Aspen. Aspen's a massive, very good software that we use in chemical engineering. And we also have a couple of other compulsory technology modules. So I think we do Lean Six Sigma, which is offered to us. And I'd say on that respect, Imperial was very good in that they give us the opportunity to study things other than hard sciences.
Well, that's actually very impressive that your university has put aside a great deal of focus on these additional aspects of chemical engineering. Because I can tell you, a lot of people that I've spoken to around the world, they don't really put that much focus on these topics, which is quite sad. So that's great. So you are in very good hands when it comes to very additional aspects. So that's great. Thank you very much for sharing that.
Thank you for listening. And if you have not done so already, remember to become a free member at Chemical Engineering Life. And do not forget to like, share, and subscribe to our YouTube channel, and stay tuned for more upcoming podcasts with chemical engineers. Thank you, and have a great day.